we want to talk about the different communication options that are available on the Aquatrack Heritage controllers, so that when you are trying to look at your program or program the controller, or if you're trying to just monitor the information that's on your controller, what different options do you have? The basic option being the keypad, but very much more powerful communication method would be using your computer with either a browser or Trackster, which then could be used over a wireless connection from your home or anywhere in the world. And also, some of the controllers offer the old style phone modem communication method. And here we go. So today we'll talk about the keypad menu. We'll talk about how to connect with an Ethernet port locally and remotely, and also we'll cover the phone modem. The keypad, the best idea is to think of how we are displaying the information when using the keypad. When you power up a controller, you can see here at the very top, you have the system menu when you first power up a controller. And from here, if you use an up or down arrow, you will scroll through all the different menu choices in the controller. I should give a better spotlight here. So as you use the up and down arrows, you can travel around the menus. The higher level controllers, like the Multiflex and the Aegis, allow for one complete loop. If you just press the up arrow only, the up arrow being this tan arrow, you would go backward through the menu. If you use the down arrow, you would go forward through the menu. And what will happen is you'll see all of the I/O points that are currently enabled in that controller. If at any time you press the enter key, green arrow, you would drop down into a submenu for the option that you're currently looking at. So if you're at the first menu choice and you press enter, you'll see the options that are available for that particular menu choice. Typically after the first system menu, where you can see the IP address and the time and date, if you go over to the first menu choice, that's usually the alarms. So you could go into the alarms menu. If you were to continue around the menu tree, you would get to the first I/O point, which could be conductivity sensor or an inhibitor relay. And if you press enter at that point, you'll go into the options for that I/O point, so that you can calibrate that I/O point, or you can change the alarms. You can look at the diagnostics. And once you go into a submenu for any particular point, there are other options underneath which are accessible through the enter and escape key. So as you press the enter key multiple times, you will go deeper and deeper into the menu for that one item. The escape key then would bring you back up to that one item, and then you can use the up and down arrows to travel through other I/O points. This is the basic understanding of how the keypad menu works. Not as good with this pen as I would like to do. Okay, so to show you with displays exactly just what we just talked about, in the upper left-hand corner, you can see here's the power-up display of a multiflex. This is what you would actually see: the system name, serial number. The second line, the third line would be the alarms and the current time, and then if there were any alarms, they would be listed here. Notice that we have a broken arrow, if you will, and a regular arrow. This broken arrow is what we call the cursor. It means that this is the line that you're currently on. If you press enter, you would go into the system menu, and the system menu looks like this. You have a choice of diagnostics, enabling I/O, configuring the system, and if you were to press the down arrow, you would have more choices. you press the up arrow, then you would come back up through the menu. If you press the escape, you'll go back to the system menu, and the up and down arrows would choose the next choices as we described in the last screen. If you pick the enter key, then again, wherever the cursor broken arrow is, that would take you into that particular submenu. So with the cursor sitting in front of the diagnostic line, if I press enter, then I'll get to see the diagnostics for the system. And the diagnostics are, first you would see the firmware version, and you could see how much current the controller's using, if their relay fuse is okay. So these are all system diagnostics. Using the up and down arrows, we can scroll through the diagnostics for the system. If we were to move the cursor down one step, then it would be in front of Enable I/O. Now, if we press the enter key, we're in the Enable I/O submenu, and we can start turning on disabled inputs, or we could go down and turn on disabled outputs. Again, if you press enter, then you'll get to see the inputs that are currently disabled, and so on and so forth. So, as you can see, the top display allows you to go using up and down arrows through all the I/O choices. Once you enter into any particular choice, you have submenus that are related to that particular item. So the second communication choice that I'm going to speak about today is the Ethernet connection, and how to configure your laptop or your PC to communicate with any of our controllers requires that you set up your laptop with an IP address. And doing this takes about 30 minutes, and we don't. The discussion takes about 30 minutes, so we'll set that up for another discussion. There is, however, on our website, if you go to the prominent.us website, you can do a search for the word setup, and you will find this how to set up computer IP address document, and you could look through that. That's another webinar, if Jim allows. We'll do that in a few weeks. So simply stated, you connect your PC directly to an Aegis or multiflex, PromTrack, SlimFlex, Microflex using an Ethernet Cat5 crossover cable. You set the IP address and then open up a browser and enter the target IP address, which would be the address of the controller that you would communicate with, and you would set up an Ethernet connection. There's certainly a lot to talk about with Ethernet. There are many ways to communicate with controllers using Ethernet. Basically, Ethernet is a two-way communication that allows you to send large amounts of data back and forth to controllers or to your PC. And this picture is showing a little bit of information about how controllers can be on a network or a LAN, and they can also be connected to the internet, which would allow communication from anywhere in the world with these devices. We'll talk more about that. So communication between two or more devices can be via 4 to 20 milliamp signals or Ethernet. 4 to 20 milliamp signals transmit in one direction only and handle only one analog signal. They don't transmit digital signals. Multiple items require multiple 4 to 20 milliamp loops. So if you've had pH, conductivity, and ORP signals, and you want to send them to someplace else, you want to control a pump, or you want to send it to the plant DCS, each signal that you send has to have its own 4 to 20 milliamp loop. It's only one direction. It sends the conductivity value to the DCS or to the pump or to the valve. Ethernet communication allows for more robust communication of information and is two-directional. So devices can pass information back and forth. Ethernet uses languages to talk. So our controllers use HTTP, which allows browser language, so that if you open up a browser, you can communicate with the controllers. Some of the controllers have that as an option, but the multiflex, the Aegis, and the PromTrack have that as a standard. The Aegis also has the multiflex Aegis and the PromTrack also have the Telnet language, which allows the Trackster 3 communication, and the Aegis as an option has a Modbus communication. We'll talk more about the browser connection and the Trackster 3 connection. The Modbus communication is, again, an item for another day. There's just way too much information there. But basically, Modbus would allow this controller to talk to the plant DCS, and then the plant DCS can go in and get all the information, set points, current values, whether a pump is on or off, whether it's an alarm, etc. So using a browser connection, for example, here we see a multiflex connection in the live view, which we call the green screen. I'm not sure why we decided to call it green screen. We have the ability to put some names at the top. On the left, we have the menu bar that allows us to navigate through the browser. The top line, we have the current time and date. If there are any alarms, then we'll see a button which we can press and open up an alarm screen. Here's how you press this button to log in, and we can always refresh the screen because the screen actually doesn't update live. It updates about every 30 seconds. So in other words, the information here is only refreshed every 30 seconds. You could refresh it manually at any time. So we can see that if we have a conductivity sensor and perhaps we are controlling a bleed valve, the controller will, once you program it, the screen puts those two items together to make it easy for you to see that the bleed valve is or isn't turning on when it's above the set point. If we happen to have a 4 to 20 milliamp output on our conductivity, then it groups that in here together so that you can see these three items are together. That makes sense that they're together. The next item we had was a pH sensor, and it's apparently controlling an acid pump, and we are also using a 4 to 20 milliamp output card to send the pH signal to perhaps a DCS or a chart recorder. Next, we have an ORP sensor controlling an oxidant pump, and we didn't choose to put a 4 to 20 output on this particular item, so there's none here. Perhaps you have a makeup meter and running an inhibitor pump, and so you can see we've grouped together any relay that's being programmed by a sensor. So that makes it easy to look through the menu and see how things are going. Other sensors that are not currently controlling any outputs are put into the monitoring section. So we have a temperature, have a local temperature here, and it was a balmy 31 degrees the other day. That's nice. It's certainly a lot less than that today. And some extra I/O that are in this particular controller. If I have any relays that are not currently programmed, then they'll be put into this section. There's also another section for timed events, which would be relays that are programmed, but they're not using any sensor. So they're not grouped with any sensor, so they're not in this section, sensor and controlled output. They have their own section. And this is called the view screen. If you ever press the view button, you're brought back to this main screen where you can see the main items. So first thing you'd want to do is press the login button. Typically, you would press the admin button to get the ability to do anything that you need to do. Some of the users there's up to 7 user accounts that can be set up. Typically for operators, each one has their own account, and since there is a device that tracks changes that are made and who makes those changes, it would be easy to see if a person needs more training or not, if they're making changes and they're not understanding. So there are 8 total accounts that you can use, that you can set up for this controller. You would highlight the admin, put the password in where the 3 dots are, press submit. And then once you've done that, you would see, instead of the login button, you'd have the name of the account that has logged in the admin in this case. And from there, we can start to go through a little bit of understanding of what the menu does. If you click on sensors, then just like we talked about in the keypad menu, you would see the choices that you have for sensors. In this case, you can calibrate a sensor, you can set the alarms, configure the menu, configure the sensor, or look at the diagnostics. So those are the activities that you can do. And then over to the right, you would choose the connectivity. You can hit the drop down arrow. You can pick whichever sensor you wish to calibrate or set the alarms for, and press the submit button. So once you choose the sensor from the drop down menu, and then down in the lower right corner, you can see what the drop down menu looks like. This is going to change for every controller because this is a cooling tower controller, for example. So I have a connectivity, temperature, pH, ORP, etc. Your controller could be a boiler controller, in which case you would see a different set of I/O, whichever inputs and outputs you have enabled on your controller. That's what you'll see in the drop-down. For the relays, or the controls, select the controls from the menu. Again, you have an activity, diagnostics, configure, alarms, etc. And then select the output, press submit, and now you can change the alarm points or configure those I/O points. The alarm button shows current alarms. You can clear the alarms. You can see when they came in and which alarms are there, which helps you to determine what problems you may be having with your controller. The system menu button has quite a list of items you can check. Looking simply at diagnostics is a good thing to get an understanding of what all is available in the system menu. You can enable an I/O here, change your login, look at alarms, set the time and date. If your controller would need to have an upgrade from our company, there's an upgrade page, system alarms, configuration for the system, and setting up password. And lastly, communicate is setting up your IP address, and also if you have a phone modem, this is where you would configure that. So the browser screens allows us a very simple, direct manner to access and monitor and edit all your I/O system parameters and alarms. The items on the screen, view screen, line up in the same order as in the I/O of the keypad. So when we were talking about the top part of the screen where the conductivity and the blowdown valve were together, that's the way they would show up on the keypad. But first, as you press the down arrow, you would go from system to alarm, and then your first item would be conductivity in this example, and the second item would be the blowdown valve. The third item would be the 4 to 20 milliamp output. The next item would be the pH, and so on. So they line up the same on the keypad menu as they are in the browser view screen. The browser doesn't require any software. You have any browser that you have on your Windows-based computer will work. Windows operating system, as late as Vista, do not require a crossover cable. Any Ethernet Cat5 cable will work. Earlier versions, though, the computer isn't smart enough to know how to test for which direction the cable should be, so you have to use a crossover cable. Tractor 3 software has the same information basically as the browser, but it also allows you to download data so you can make graphs, and it has the live view section, which allows you to make a picture instead of a green screen. As this is especially good for customers where they can have the actual boilers or cooling towers displayed on the screen. They can see The pumps change color when they're on or off, and they can see the value of a sensor right as it appears on the screen. So that's what Trackster helps bring to the communication package. Another example of a Trackster live view, this one for cooling towers. And so you can see there's all the information about the application here. We have a disconnect button. We have the download data button, which would allow us to collect the last week or 2 weeks or 3 weeks of information that's been stored on the controller so that we can make a graph and present to our bosses or our customers or whoever how well the process has been working. One more picture again. These can be edited by the user so that they fit their particular system. This one has one cooling tower and 2 boilers, all on one controller. So Trackster 3, to install and run Trackster 3, you can navigate to the prominent US website, select products, controllers and monitors, select Trackster 3, the bottom of the list, and that allows you to download the Trackster software. And I'm very quickly going to go into installing Trackster slightly. To install and run the Trackster 3, you would follow the instructions to create a system or a plant and then populate it with controllers. In other words, once you have Trackster 3 up and running and you want to add your controller to Trackster 3 so that you can connect to it, there's in the startup screen, there's instructions on how you add a system and how you add a controller to set up your Trackster 3 software. So you basically would highlight the Trackster component bar, select the system icon down here, and then enter a plant name. Example here, McDonald's. Press apply and OK, and now you have created a McDonald's site. So now we would add, press on the controller icon so that we can add a cooling tower or boiler controller. In this case, I've selected going to be 2 towers, 6 and 7. Make those changes, and now we can connect to the controller. There'll be a blue connect button. Press the button, enter the password. The default password, if you haven't changed it for the admin, is 4 capital A's. And it'll ask you to pick a live view. I would start out with the diagnostic view. Diagnostic view simply shows all the information that you have on the controller, whether it's enabled or not. That way, if you have a live view, you're not going to miss any information. The diagnostic view, as I said, shows all the different I/O points. Any grayed out icons just means they're not used. You can go into the system and enable them, as we mentioned earlier. If you double click on a colored icon, it opens up a properties window, and the properties window lets you edit the I/O point the same as you could with the browser or the keypad. So now, excuse me. So in this example, we have double clicked on input letter P, and we see that we have the general information here. It's a water meter. It's log period 60 minutes. It's in gallons, etc. And we can set up the alarms or calibrate or look at the diagnostic screen, same as we could with the browser or the keypad. Once you've downloaded data, you can create graphs of different information, bleed valves, conductivities, what have you. And so that's very basic information on Trackster, which we will probably offer a webinar in the future on just Trackster. So let's talk a little bit about wireless communication. If your controller in your customer's plant, you want to be able to connect to that controller from your office or from any place, and the customer will not allow you a VPN, which would get you through their firewall, which is typical. then you could purchase a wireless option which would connect your controller to the internet rather than the plant's local area connection, the plant's network, in other words. Once you connect a controller to the internet, you can't at the same time have that controller on the plant network, because now the plant network would be on the internet. And obviously, customers go to a lot of trouble to erect a firewall, if you will, that protects them from people outside their company getting into their business. However, once your controller is wirelessly connected to the internet, then anyone who can get to the internet and knows the IP address and knows the password, including your customer, can connect to the controller. So now your customer, he doesn't have the controller on his network. He can't directly connect that way, but he can still connect just as anyone else can to the controller. And now he can use a browser connection or a Traxtor 3 connection. Another way to connect to a multiplex is through a old-fashioned phone modem, shown here. That's something that the Octrek line has been offering since they started up in, I think, '92. Your computer would have to have a phone modem and a telephone line. This used to be so common, and now some of you maybe have never actually done that. This requires Traxtor 3. The browser is an internet product. We're using telephones, old-fashioned telephones, landlines, okay? Then you need to have a telephone modem and a telephone landline.